guys, today's lesson is on parallel and perpendicular lines. We will be writing equations for parallel and perpendicular lines in slope-intercept form, but before we do so, we're going to investigate their slopes. So the first problem below, we have a coordinate plane, and we're going to graph the two equations to the right. The equation in blue, I'll graph in blue. It has a y-intercept of 1, so I will plot that first, and a slope of 2. From that point, I will go up 2 and write 1 unit, and then graph our line. The second equation, written in red, I will graph in red. That has a y-intercept of -1, so I'll put my first point on the y-axis at -1, and it too also has a slope of 2. From that point, I'll go up 2, write 1, graph my second point, and graph the second line. As you could see, these two lines are not touching each other. They would be represented as parallel lines or described as parallel lines. Notice that the slopes of these two lines are the same. They both had a slope of 2. One important thing we need to know about parallel lines is that they have the same slopes. So down below, what we're going to do is write an equation of a line that's parallel to another line. This is just a way of knowing what the slope of your line is going to be. For example, in number 1, we wanted to write an equation in slope-intercept form that passes through the ordered pair -1, -2, and is parallel to this equation, y equals -3x minus 2. If the equation that we're going to write is parallel to that equation, we'll have the same slope. So over near m, I'm going to record that our slope will also be -3. The only thing left to do is find b, or the y-intercept. As we did in previous lessons, we're going to substitute the values into our slope-intercept form to find b. Since they gave us an ordered pair in our directions, that is going to give us an x and y value. And since we know m is -3, we'll plug those three numbers in and then solve for b, or our y-intercept. In this case, y is -2, m is -3, x is -1. Let's go ahead and simplify and solve for b. -3 times -1 is +3 plus b. I'll subtract 3 on both sides to get the y-intercept of -5. Now that I know both the slope and the y-intercept, we know now we could write our equation y equals -3x minus 5, which is our answer. This equation is a line that's going to be parallel to the line that they give us in the directions, but will also pass through the ordered pair that they give us through the directions. We know the two lines are parallel because they have the same slope. Let's go ahead down to number 3. We're going to do the same steps here. They give us an ordered pair and a line that we want to write a line parallel to. If our line is parallel to this line, all that means is that we're going to have the same slope. Since that line has a slope of 1/4, our line will have a slope of 1/4. All we need to find is b, or the y-intercept. So we'll plug in the ordered pair and the slope into our slope-intercept form to find b. In this case, y would be -1, m is 1/4, and x is 4. When we multiply, 1/4 times 4 is 1 plus b, and we'll subtract the 1 on both sides to get b is equal to -2. I'm going to go ahead and record it on the left. Now that I know what the slope and the y-intercept is, we can now write our equation in slope-intercept form, y equals 1/4x minus 2. Our equation will be parallel to the equation that they gave us in the direction since they have the same slope. However, our line will pass through the ordered pair that they give us. What I'm going to ask you guys to do is pause the video, try number 2 and 4, Once you get your answer, go ahead and play the video to check. Here are your answers for number 2 and 4 on our first page. Remember, parallel lines have the same slopes. So for number 2, if the equation that they give us have a slope of 2, then we're going to have a slope of 2 because our line will be parallel to their line. Finding b, we're going to plug in 0, -1 and the slope into y equals mx plus b and find that b, or the y-intercept, is -1. Once you know what m and b, or what the slope and y-intercept is of our equation, we could then write our answer, y equals 2x minus 1. Down below for number 4, the slope in their equation is 1/2. If my line is parallel to their line, we'll have the same slopes, therefore our slope will also be 1/2. We'll plug in the ordered pair -2, -1, and simplify to find b, in which you'll find that b, or the y-intercept, is 0. Once you know both the slope and y-intercept, we could write our equation, or our answer, y equals 1/2 x. We're not going to add the plus 0 on the end since we don't want to have 0 in our equation. The second page we have in our notes here is going to introduce perpendicular lines. At the top, we're going to graph 2 different equations and see what they look like on the coordinate plane. The first equation, written in blue, I'm going to graph in blue. It has a y-intercept of 1 and a slope of 2. So I'm going to put a point on the y-axis at 1. From there, I'm going to go up to right 1, plot my second point, and graph the line. The equation in red to the right, I'm going to graph in red on the coordinate plane. That has a y-intercept of +2 and a slope of -1/2. So from my first point on the y-axis, I'm going to go down 1 and right 2 units, and then graph my line. As you can see, this is different than the first 2 equations, or the first 2 lines we saw on the first page, because they do intersect each other. These aren't parallel lines, these are perpendicular lines. And I know that specifically because the slopes have a very special relationship. Perpendicular lines have what's called opposite reciprocal slopes. Opposite refers to the sign. If one slope is positive, the other will be negative. And reciprocal was that fancy word that means to flip the fraction upside down. So before we begin, let's practice identifying opposite reciprocal slopes. Let's find the opposite reciprocal of the following values. Over on the left side, we have the number 1/2. Since it's positive, the opposite would be negative, and the reciprocal would be 2/1. Remember, we're just flipping the fraction upside down. The numerator will become the denominator, and the denominator will become the numerator. We will simplify if we can. For example, in this case, -1 divided by 2, -2 divided by 1 is -2. So the opposite reciprocal of 1/2 is -2. Let's go on below. -3. The opposite of a -3 would be a positive number, and the reciprocal of 3/1 would become +3. The opposite reciprocal from, oh crap, I messed that up, would be 1/3. The opposite reciprocal from -3 would be +1/3. Let's find the opposite reciprocal of 2/3. It's positive, so the opposite would be negative, and the reciprocal of 2/3 will be 3/2. Opposite sign, and flip the fraction upside down. The number 1, since it's positive, the opposite would be negative, and to find the reciprocal of 1, I can make it a fraction, 1/1. But as you can see, if we flip that upside down, it will still say 1 over 1. So the reciprocal, or the opposite reciprocal of 1, is negative 1. Down below that, in our next section, they're asking us if the pairs are perpendicular. For problem number 1, the slopes are 2 and negative 2. Are they opposite signs? Yes, they are. But are they reciprocals? No, they're not. The reciprocal of 2 would be negative 1/2. So number 1 would be no. And for number 3, are those two opposite reciprocals? We have a positive 4 and a negative 1/4. They are opposite signs. The only thing left to check is if 1/4 is the reciprocal of 4. Since it is, we're going to say yes, these will be perpendicular because their slopes are opposite reciprocals. What I'm going to ask you to do is pause the video, try all the problems to the right in both of the sections. Once you get your answer, play the video to check. Here are our answers for the second page. The problems to the right-hand side in the first section is asking to just find the opposite reciprocal of the number listed. The opposite of negative 1/3 would be positive, and the reciprocal would be 3. So our answer is positive 3. The problem underneath, positive 2, the opposite sign would be negative, and the reciprocal of 2 is 1/2. So the opposite reciprocal would be negative 1/2. The opposite of negative 3/4 is positive, and the reciprocal of 3/4 would be 4 over 3. And lastly, the opposite of negative 1 will be positive, and the reciprocal of 1 stays 1. So the opposite reciprocal of negative 1 is positive 1. Down below, they're asking if the lines are perpendicular. Let's check out the slopes for number 2. 1/2 and negative 2 are opposite signs, so they are opposite. 1/2 is the reciprocal of 2, so they're also the opposite reciprocals. Therefore, yes, those two lines would be perpendicular if you were to graph them on a coordinate plane. And number 4, the slope for the first equation would be 1. The slope for the second equation is negative 2. Although they are opposite signs, they are not reciprocals of each other, so we would say no. If we were to graph those on the coordinate plane, they will not be perpendicular. Let's check out our last page here for our notes. It's going to be very similar to the first page when we had parallel lines, but now they're asking us to write an equation in slope-intercept form of a line that's perpendicular to another line. For example, let's check out number 1. If my line is perpendicular to this line, or our equation is perpendicular to that equation, our slopes would be opposite signs and the reciprocals of each other. Since their slope is negative, my slope will be positive. What would the reciprocal of 3 be, or 3 over 1? If I flip that fraction upside down, we would get positive 1/3. Now that we know what our slope's going to be, let's find our y-intercept by plugging into our slope-intercept form. The ordered pair that they give us, negative 3, 1, is going to represent the x and y values, where y will be 1, m is 1/3, x is negative 3 plus 1. I'll go ahead and multiply. 1/3 times negative 3 is negative 1. And to solve for b, we'll add 1 on both sides to get b, or our y-intercept, is 2. Once we know both our slope and y-intercept, we could write our answer, y equals 1/3 x plus 2. If we were to graph our answer on the coordinate plane, it would be perpendicular to the equation they give us in the directions. Let's take a look at another one, problem number 3. If our line is perpendicular to this line, the slopes would be opposite reciprocals. The opposite sign of the slope in their equation is negative, so ours will be positive. The reciprocal of 1 over 4 would be 4 over 1, or just positive 4. Let's find our y-intercept by plugging into our slope-intercept form given the ordered pair -3, -2, where y is -2, our m or slope is 4, x is -3, and we'll simplify to find b. 4 times -3 is -12, and when I add it to the other side, we find that b, or our y-intercept, would be 10. I'm going to record it over on the left side, and we can now write our answer, y equals 4x plus 10. The equation that we just written is perpendicular to the equation in the directions. What I'm going to ask you guys to do is try number 2 and 4 on your own. Pause the video. Once you get your answers, go ahead and play the video to check. Here are your answers for the last page, number 2 and number 4. In problem number 2, their slope is positive 1/2. If my line is perpendicular to that line, we'll have the opposite sign. Their slope is positive, so mine would be negative, and the reciprocal of 1/2 would be 2, so our slope would be -2. When you plug in the ordered pair that they give you, 0, -1, in addition to our slope, we'll find that b, or our y-intercept, is -1, in which our answer will be the equation y equals -2x minus 1. Lastly, number 4, their equation has a slope of positive 2. Since their slope is negative, mine will be positive. Since their slope is positive, mine will be negative, and the reciprocal of 2 would be 1/2. So our slope we're going to use is -1/2. When I plug it into slope-intercept form, including the ordered pair 2, -1, we find that b, or the y-intercept, is 0. Therefore, our equation will be y equals -1/2x. Please let me know if you have any questions on the